I promise this thumbnail and title is not clickbait, but spoiler alert, I didn't charge $1 million to make these parts. Actually, it was just a tiny itty bitty fraction of that, maybe. Just, yeah. But if you've ever read any of the comments on my other videos where I reveal the pricing and you probably sided with the people thinking that there's no way that we make this kind of money in this business doing small parts and repairs, right? If you've ever thought that, you need to watch to the end. Now, this part was dropped off by the customer and it's made of cardboard, which is not a language that the Fast Cut speaks. So we got to draft this thing up, program it, cut it out, clean it up, and hope that my screw up didn't cost me too much money on this one. And of course, the $1 million question will be answered only on this episode of the fabrication series. Just to show you guys that I'm not messing around here, I have the timer. Let's start that. Right, we're going, everything's running. I'm gonna push record on my screen here so that way you guys can follow along. And look at that, I've already lost 8 seconds. So this is Solidworks. This is what I use for basically everything. And once upon a time, I used Mastercam, but I no longer use Mastercam. So the general shape of this, right? He only left me a couple dimensions, 2 1/8 square. That's the only thing we have to worry about there. And then he did not leave the dimension for the distance between the bottom and the bottom of the square, and then the left or the side of this and the side of the square. So I measured those out, verified with him. They're 1/2 inch and 3/4 inch respectively from this corner. So that's all the dimensions I have. Once we start drawing this and define it, then the rest of it will populate. Like, I don't know what that angle is. We'll figure it out later. I don't really care. So first I'm gonna do is draw a line. And that's it, just a friggin' line. Make sure that's horizontal, make sure that's perpendicular to that. It kind of angles up in this general direction. That goes vertical, that goes horizontal, and actually what I wanted it to do was go from here. Normally I would do this in one piece, but I guess because I'm on camera, I'm camera shy or screwing all of this up, you know, who knows. All right, general shape there is finished. Let's just give this thing some dimensions, right? We'll start with the bottom here and I'll work my way around and then we'll go up that way and then this angle and length should populate automatically. I'm not even gonna measure it. First measurement at the bottom, we got 10.5 inches. So clicky clicky on that line, 10.5 inches. This side right here, 7.5 inches or 7.5. For all of you that speak metric, sorry, I don't. Or I do, but it's not my native measurement. So, you know, translate it in your head if you don't like it. This up top here, 5 1/8. So 5.125. If you guys are actually following along here, you see how close I actually got these dimensions. This one right here, that is 1 and it looks like 11/16, so that's 0.6875, 6875. Maybe it's because I'm using a different keyboard than usual. I actually have a keyboard right now, I don't. This measurement here, as long as we get this correct, then this will automatically define, populate the dimension, all the rest of that stuff. 3 1/4 inches. Now the customer did specify that this is general, just rounded up to whatever. I probably didn't have to round it all the way up to like a 1/16 of an inch or whatever the case is on that, 11/16, but hey, that's what it measures. We're gonna get it as close as possible. Everything else is pretty much dead on as he cut it. So the whole design of all of this, the whole perimeter, all that stuff, we're set there. All we need to do is add a square, which I could have probably just threw this in there. Originally, not that big of a deal. Could have just tossed it in, you know. We'll move that down there. The dimensions, it is 2 1/8 square, so 2.125 by 2.125. I feel like I'm losing time just by talking to you guys, but that's okay. This dimension from here to there is not 0.23, it is actually 0.75. Voila. And here to here, or as the French would say, ear. From ear to ear. My apologies if you're French. I don't want to offend anybody. All right, we have all of our dimensions. Everything's fully defined. Now we go to, no, we don't want sketch, we want features. We'll close out of that, discard, yada, yada, yada. Okay, now we want to extrude. We'll click on that, and then we'll clear that out of the way so it opens up that hole. We want 0.25 inches, which, strangely enough, that's the last part that I built was 0.25, so we're good to go there. And here we go. Here is our, no, that's Control 5. There we go. Here's our part. It looks pretty close. All right, now all we gotta do is click that, say export DXF. We'll send this to the fast cut, which is pretty quick. We'll call this the weird bracket thingy. Sure, you know, because I don't really need to know exactly what it is. Click on that. Here is a sketch outline. Yes, that is what I want to cut out. That's what the computer will talk to. Send that to the fast cut. Let's go get that out of the way. This took exactly 5 minutes, 2 seconds, 0.94. Let's go cut this thing out of the fast cut.
Now, this clip that you're watching right now is of me clearing off the last job that I did on the fast cut and loading on the metal that the customer supplied. Now, this is a real-time clip, and it's only 30 seconds long. I probably could have done a little bit faster if I wasn't using only one hand, but realistically speaking, it doesn't take that long to load material like this for small jobs. I mean, people act like it takes like 10 minutes or something to do. Maybe they just took too many smoke breaks or something, I don't know. But for what it's worth, it also takes only 12 seconds for me to get from my office to the fast cut out in the back shop. I mean, I time everything because efficiency is key. It's extremely important to know actual numbers so you can get actual amounts of money that you're making or losing. Anything you can do to increase efficiency, you should do. Even things like my Hypertherm, which has just been upgraded to the sync system, which uses these complete cartridges instead of individual consumables. It's actually pretty genius because it saves a ton of time in between setups, and it definitely reduces errors because these individual cartridges are always set for optimal cutting. There's really nothing you can screw up. I mean, this is kind of how it works.
Those fresh Hypertherm new plastic peel feels. I'm gonna leave that there actually because I kind of like it. Hit the resweat. All right, so you can see we have a 45 amp cartridge on 45 amps because there's a 45 amp cartridge in there. Twist it this way, just like that. Comes off. This is a 65 amp. Stick it right there, twist that on over there, and voila. You push the resetsies. And 65, just like that. If you were wondering what I was clicking, that's this switch right here. So disable, enable. Remember before on the other Hypertherms, you had to go back there and then turn the switch off and then go back and reset this and all that crap. You know what, that stuff's gone. That's long gone, right? So we're in sheet cam. I've already measured my available material, which is like 24 by 15 and a half. So funny looking bracket thing. We'll open that up. Yeah, you know what? Let's just hit this with the program. Now, FastCut was kind enough to update my Hypertherm tool library. So all of these are with the new sync controls, and they are different than the regular Hypertherm. So make sure that when you update or upgrade or whatever the case is, or buy new, make sure that your manufacturer has put in the correct library for the sync machine itself, because it is definitely different. So
okay, so it was getting a little bit noisy between the garbage truck out back and of course my employees doing their job out in the shop, so I had to switch to voiceover because I'm not going to stop them, of course. And this stuff also kind of gets a little boring when you're just hearing me talk about it or whatever, so I did speed it up, but the complete elapsed time was 3 minutes. Seriously, that's all the time it took to nest these 4 parts and post it into the FastCut. Now, cutting the parts out was actually a completely different story here. This was actually supposed to be like completely textbook. Nothing new, nothing unusual, nothing difficult or different about this, right? It was just running it. But at some point in time, I must have accidentally shut off a function or something like the torch height controller or, you know, whatever. But I noticed it wasn't cutting optimal, right? It was like, you could see that there's like some top dross on it, and it was cutting like this V groove into it, like the torch was way too high. And you can actually see at some point in time here, the torch attempted to fire ridiculously high, and it sort of got through. But by the time I caught it, it was a little bit too late because almost 3 parts were already cut. But I did eventually find the problem, correct the problem, and then refire it, which means I got one good part out of all three of these, which that's kind of a fail here.
Obviously, this is not what is to be expected from Hypertherm. This is what is to be expected by somebody who forgot to double check that the settings were correct on their table.
Yeah, bummer, right? Well, I can't really do anything about this except for take the loss on round one. I'll accept the fact that I screwed this up and I can't fix it, and of course I'll have to go back in with my own metal this time because I screwed up the customer's metal. But this time I made sure the settings were correct, and what a friggin' difference.
Okay. Let's turn off the compressor so you guys can kind of hear me real quick, right? Just cut, literally seconds ago. And there we have it. That is insanely clean. Like, I don't have to really do anything to this. This is literally book setting. 65 amp cartridge. Just a little bit of dross that, I mean, that could be picked off with a screwdriver. I mean, some of it's just flaking off with my fingers. That is super legit. And it took a grand total of 2 minutes and 28 seconds, so we'll be sure to bill for that. Even though the customer supplied his metal and I screwed up, I'm just gonna obviously give him these once I get him cleaned up. No charge for that metal.
Probably the most amazing part about this one is how little time it took to actually clean these parts up. Like, I can't really express how delightful it was to do. Primarily because the Hypertherm and how it actually cuts these and how very little dross it left behind, that was just absolutely phenomenal. So it only took a grand total of 4 minutes to clean these parts up and one piece of sandpaper. Not bad.
So, on to everybody's favorite part. How much did I charge the customer to cut these 4 pieces? It was actually 5, but we're only charging for 4, right? My bad. Well, $50 is my drafting fee. It is a flat fee. I do not charge tax on it because labor is not taxed where I operate. This fee also covers CNC work or other expenses related to CNC work, like the $8,000 software I have to use, right? That stuff is expensive. 3 minutes to nest and ready the code for the fast cut. That's how long it took. That's it. Everybody thinks it's longer, but it's actually not. Now, I did talk about and demo the Hypertherm sync cartridges for you guys on camera, which took a minute longer than usual, which I didn't charge the customer for. And of course, you saw that swapping the cartridge literally only takes like 2 or 3 seconds to do, which makes it an extremely efficient setup. 2 minutes and 30 seconds were cutting these parts, and 4 minutes were spent cleaning these parts. Now, all of this actually rounded up because it does take a couple of extra seconds to walk from one station to another. Now, if it takes longer, either your shop is not set up for efficiency, or it's just friggin' huge. But even huge shops should be set up for efficiency. Rounding it up is always kind of a good idea because it covers like the little expenses or the little other things like running the air compressor for, you know, that amount of time, which the air compressor is usually the least efficient machine in like everybody's shop. So that's a grand total of $15.85 for the labor and 40 cents for the sandpaper. Now, the Hypertherm and Fast Cut are very efficient machines, which literally only take pennies to run for 3 minutes along with the grinding table, right? It's almost nothing. Now, had I not screwed up the customer's metal, my profit for roughly 15 minutes worth of work would be $66.25. However, if we do the math on the remnant 312 square inches of 1/4-inch steel I had to provide after I screwed up, I actually only made $21.61 because the steel cost $44.64. Bummer. Now, some people aren't afraid to voice their opinion in the comments or even in person, saying that I'm not charging enough and there's no way that somebody can live off of 66 bucks. Now, that's only like $8.25 an hour if you do the math on it, and if that was the only job I had that day, it would be tough. But if that was only one of 4 jobs completed in that hour, all similarly priced, that's $264 per hour. If I worked only 8 hours a day, that's $2,000 per day. And if I only put in 40 hours a week, that's 42 grand a month, or just over $500,000 per year. But if you're like most business owners who average 80 hours per week, that's 84 grand per month, or $1 million a year. Crazy, huh? 15 minutes could end up grossing you $1 million a year. That's the exact same amount of time it takes to watch this entire video.